Now we're going to look at transformations that we can make to the sine or cosine graph that affect the sinusoidal axis, the amplitude, the phase displacement, or the period. So the first thing we're going to look at are changes outside the function. Changes outside the function affect the y direction. And when I say changes outside the function, I mean that what we're doing to the sine function does not occur inside these parentheses, it occurs outside the entire function. So notice here that we have a sine graph here. So this bottom graph is the sine graph. And then we have another graph that is this first graph just shifted up. Notice that every point has moved up exactly 2 units. So we went from 0 to 2, or from 1 to 3 in the y direction. So everything has shifted up 2. So what makes all the y values shift up 2? The x values have not changed. For example, this is the point 91. And actually maybe I'll write it underneath here since I drew that arrow in already. This point right here is the point 90 degrees 1, and this is the point 90 degrees 3. This is the point 180 degrees 0, and now this is the point 180 degrees 2. And so this is true for every point. Every point has shifted up from a low. So if we look at a low value here, let's do one more. 270 negative 1 to 270 positive 1. So to shift every point up 2 units, we just take the sine graph and we just add 2. So you put in your value for x, you find your value for y, and then you add 2 to that number. So this is a transformation that is just merely adding to the function. Now, what I want you to notice is what this transformation does is it change which of those 4 characteristics has changed. Is the period changed? Does one cycle take longer to go? Is the amplitude changed? Does it stretch up and down farther than it used to? No, it is the sinusoidal axis that has changed. And this number out here that we added is the sinusoidal axis. That is the new sinusoidal axis. It used to be at 0, now it's at y equals 2. Now let's look at the next characteristic. Here I had the graph drawn, and I just was helping you recall that in our transformations before that we've done, we're adding 2 to everything. Now let's look at multiplying by 2. So here's our original cosine graph. Cosine is also a sinusoidal function because they're exactly the same curve, just shifted. And once you start shifting and moving them, it really doesn't matter whether you call it sine or cosine, it's still the same curve. And we'll look at how we do that later on. So 2 cosine x. So let's think about what happens here. If we have a point that, for example, that cosine of 0 equals 1, what would 2 times cosine of 0 be? Well, 2 cosine of 0 is going to be 2 times 1, which is 2. So it's going to be right here. If we have cosine of 90 is 0, 2 times cosine of 90 is going to be 2 times 0, so it's going to stay 0. If I have cosine of 180 is negative 1, 2 times cosine of 180 is going to be 2 times negative 1, or it's going to be negative 2. So notice my high points, instead of being up at positive 1 and negative 1, are going to be at positive 2 and negative 2. So here's another high point that's going to be at positive 2, another low point that's negative 2, and another high point that is at positive 2. Points that are 0 to start with, if I put in an angle and I get a cosine value of 0, multiplying that by 2 doesn't change it. I still have a cosine value of 0. Now let's take a look at a couple places where cosine is equal to 1/2. So I'm actually going to erase this because it's kind of in my way here. Wish I hadn't written it right there. maybe I'll write it up here, that cosine of 0 equals 1, and 2 cosine of 0 is equal to 2 times 1, which is 2. Okay, so that's what we have there. So let's look where cosine is equal to 1/2. So notice here that we have cosine of 60 is 1/2. So I'm going to write this down. Actually, I'll write it over here with the cosine. Cosine of 60 equals 1/2. 2 cosine of 60 is equal to 2 times 1/2, which is 1. So instead of being at 60 1/2, now I'm at 61. And every place that I would go up 1/2, now I'm doubling that amount and I'm going up to 1. Every place that I was at negative 1/2, I would be going down to negative 1 now, because 2 times negative 1/2 is negative 1. So I can plot a couple of extra points and see what this graph's going to look like. So it's going to look stretched both up and down from the x-axis. It's 2 times taller than what it used to be. So that is what the graph looks like. So which characteristic did that affect of the 4 characteristics we talked about? Well, it affects the amplitude. So the amplitude now equals 2. So this number outside here, that's the amplitude. The original amplitude was 1. Whatever number is out there now is the new amplitude. Next, we're going to look at changes inside the function. We're going to leave that till the next video.